This question comes from exercises 6.3 and it's question number 2. And the question asks us to find a geometric power series, and this should say centered at c equals 0 for the function below. So we have function g of x, 9 divided by 5 minus x. So how can we write this as a power series? So first thing you need to do is be familiar with the geometric series. Now there are two forms of how to write a power series, a geometric power series. And this is the first one, in which the sum of it is equal to a divided by 1 minus r. And then there's this other form where the n starts at 1, and it looks like this, a times r to the n minus 1, but the sum of it is still a over 1 minus r. So r is the common ratio, and keep in mind that the series will converge as long as the absolute value of the common ratio is less than 1. So in this problem, the power series is represented with n equals 0, so we're going to use this form up here. A power series contains a variable x raised to the nth power. So a geometric power series would be in the form of n equals 0 to infinity and x raised to the nth power. So in this case, the a is 1, and the sum of it would be 1 over 1 minus x, because our r is x here. So now, so what do I notice? I notice that this, even though not exact, is very similar to this. So this should have a power series that looks somewhat like that. And this particular power series, let me move the screen over a little bit, has a center at c equals 0. If you want to write a power series centered at c, then it would look like this. But in our case, we are going to have a center at 0, so our c is 0. So we want to write this function in the form of a over 1 minus r. And so how can we do that? So let me move to a blank sheet here, and we can work on that here. So here was my function g of x. But remember, I want it to match, I want it to look like this. And in order to do that, I'll need to factor out some things. So I'm going to factor out first the 9. And it would look like this, which is, which is closer to this, but not there yet, right? And so I'm going to factor out now a 9 and a 5. So I'm factoring out the 5 from the denominator, so I have 1 minus x over 5. And so now I have this. So my r here would be this. So I'm going to write it in this form of n equals 0, ar to the nth power. So my a is 1, I still have this 9/5, by the way. And it's my R is x over 5 to the nth power. And so just continuing here, using some algebra, some exponent rules, that n applies to both the numerator and denominator. So I have this. And now exponent rules, like bases. If I have like bases, then I can combine the exponents. So my exponent here is 1, my exponent here is n, so I have 5 to the n plus 1 power, and so now I have it in the form of a times x to the n, or a r to the n power. And now I have that function g of x written in a geometric power series.